with today's first topic, that are views in SQL. So you guys have seen we have created tables. Okay, we have queried a table. Okay, now what is a view? So view is a database object that basically represent a virtual table. Okay, so view is nothing but a representation of a table. Okay, and in a particular view we can by our choice show whatever we want to show. Okay, so let me show you how we can create a view. Okay, so creating a view is similar, like we have seen all the create statements. Okay, how we create different entities in SQL. Okay, in the same way we are going to create a view. So first of all, let's create a table. Okay, I will share this complete script with you guys over WhatsApp. Okay, yeah. So I am creating a table over here, and using this table, we will be understanding what a view is. Okay. So I've created this table over here, that is shipping container. I will show you the data inside it. So I've inserted these data inside our table. Okay. Now I'm going to create a view. So what a view is, as I explained, view is a representation of our table. Okay. For example, we have seen, we have learned about joins. Okay. So if I want a user, if I want to present my data to some user, okay, by joining multiple tables, okay, I'm not going to give him a query, right? I want to give him a kind of I would say prepared data which he can just query and see what's inside that data. Okay, so for that particular reason we use view. So view is nothing but a entity using which we can share the kind of data we want our users to see. Okay, so I will create a view over here. It's a query of creating view. It's create view, view name, and as. Okay. And inside that, we will write the select statement with all the logic that we want the view to return. Okay. So I'm just returning this container ID, container type, and status from the shipping container. Okay. So the shipping container contains uh, container ID, container type, destination, and status. Okay, but I don't want the user to see the complete all the columns. Okay, so I want him only to show these three columns: container ID, container type, and status. Okay, so how I'm going to do it? I will simply create a view which will query only these three columns from the table. Okay, and return him the required output. Okay, so I've created a table view over here. Okay, so now when I'm going to query this view, select star from container status. Okay, so now when I query this view, I will only see the output of these three columns over here. Okay, so that's how I share the data with my users. Okay, the way I like. Okay, so if I want to query multiple columns, or if a particular table is having a PI information means some personal information, and I don't want to uh, down. I don't want the downstream users to get that data or see that data. Okay, so I will simply create a particular view which will contain the required columns that I want to expose, and I will share the access of that particular view with the downstream users. Okay, so that's how a view is created. Okay, so yeah. Now, views can be useful in many scenarios, simplifying complex queries. Okay, so if we are having a query that are having, like, I would say 5 or 6 or more joins. Okay, so the best way to simplify is to write multiple views. In some views, I will have 2 or 3 joins. In some another views, I will have another 2 and 3 joins. And I will join those 2 different views. Okay. So views are like simply just tables. We can perform all the operation that we perform on a SQL table. We can perform same operations over a view as well. Okay. We can perform where clause. We can perform group by. Okay. We can perform, I would say, joins. Okay. Next beneficial is it is used for enhancing the security. Okay, So as I said, if I want to share only fixed or particular columns with the user, okay, I can share it based on my choice. Okay. Moving next. Store procedures. Okay, so what is a store procedure? I hope like if you guys have worked with any programming language, you would have worked with something called functions. Okay, so there are functions in coding languages, which are like in Python or Java, we have predefined function. Okay, so in a function we have a set of code which performs some operations simultaneously, right? Okay, so the similar thing we have in SQL. Okay, so we have this thing called store procedure. Okay, so there are three different entities in SQL. First is store procedure, another one is transactions, and another one is functions. Okay, so we also have functions and we also have store procedure in SQL. Okay, but at an uber level, if I say store procedure is a pre-compiled set of SQL queries which are executed in one go. Okay, so store procedure can accept input parameters just as functions. Okay, if a function there's a function which takes in parameters, just like that, store procedure can take some parameters. So if you are familiar with Python, I would say, okay. So there's some function named as def, okay, print. Okay, so this is a function, and in this, I would say it takes a parameter x. Okay, and then there are some set of, I would say, uh, queries that are running in Python. Okay, in the same way we have in SQL. Okay, we have a store procedure where we pass parameters, and inside that we have some fixed or predefined set of operations. Okay, so how does the store procedure looks like? So just like other entities, we use this create procedure, okay, the procedure name, and then the parameters. Okay, if it takes any parameters, then fine. If it doesn't take any parameter, we can skip this part. And inside the as statement, we will write the complete queries. Okay, so in this particular example, we are simply querying a select star from the table where we are having column 1 equal to parameter 1 and column 2 equal to parameter 2. Okay, so that's how our query looks like inside a store procedure. We can pass any kind of operations inside this. Okay, but a SQL procedure should return something. Okay, so let me show you an example by creating it directly. Okay. So over here, I'm creating one store procedure. Okay, the procedure name is create procedure, store procedure. Okay, and over here, I'm taking one parameter. Okay, and with this parameter, I need to specify the data type of that parameter as well. Okay, so if a parameter is taking varchar, I need to specify varchar. If it is taking an integer, I need to specify integer. Okay, and inside that, I'm applying this filter. Select star from container status. Container status is the view that we have created. Okay, and we are applying this where clause and passing this parameter in the status. Okay, so begin and end. Okay, all the queries written inside a store procedure should be inside begin and end. Okay, that's a bit good practice. Okay, so using this, I will create a procedure over here. Okay, you'll see the command executed successfully and our store procedure is created. Now it comes how we can execute our store procedure. Okay, so to execute it, we need to use this exec, which stands for execute. So we need to write exec, then the procedure name, okay, and then the parameter values. So we are taking @param1, and over here I will pass the values that I want. Okay, so now when I execute this complete statement, execute my procedure, so it will return all the values from a particular view. Okay, where the parameter is arrived. Okay, so you just see how that happened. We are having a table, okay, where we are having values stored. Okay, over that table we created a view. Okay, so this is a view, and this view is representing the same table but only with three different columns. Okay, now on this view I'm creating a particular script. Okay, and this script, which is our store procedure, okay, it queries this particular view. Okay, and the view fetches the data from the table. So this is how we can organize our query. Okay, we can directly query data in a store procedure from a table. Okay, instead of view I could have queried directly from table. Okay, but just to show you guys how we can use view, where all places we can use a view. Okay, that's why I've used a view inside a store procedure. Okay, so that's how we, I would say, query a store procedure over here. Okay, so any doubts till now? If you have anything, put that in the QA section. Okay, or yeah. Moving forward to another example of a store procedure. Okay, over here I'm creating this procedure. Okay, where I want to get data from table sales and also data from table customer. Okay, so you can see inside a store procedure we can simply we can do any kind of SQL query. We can perform any kind of SQL query over here. Okay, so if we just remove or forget store procedure as of now. Okay, so you can see there's a simple select query. Okay, if I execute a select query, select star from sales table, there's a join on these table, and I would apply a filter of, I would say, uh, yep, just a second, start date of 2022-01-10, okay, and end date I would give today's date, so it's 2023-07, and it's 2022. Okay, so if I simply do a select on this, it will invalid object name sales. Okay. Yeah. I think there's some issue with the table. The table is not created already. Uh, just give me a second. Instead of sales table, I will use the our shipping container table. Okay, and in the shipping container table, do the join. And I will apply a filter of container ID. Okay. So it's a simple SQL query. Okay. So when I execute this query, I get some output. Okay. Now, if I just enclose this particular query inside our store procedure, okay. I'm really sorry guys. I wanted to show the example of sales table, but I don't have the script of that present. Okay. So I will show you the example of container ID. Okay. So yeah, I would pass the container ID over here. Create procedure, order info, container ID, and it is an integer. And inside that, I will have this select query. Okay. So now my procedure is created. So I will execute the order info, and I would pass the container ID as 1. Okay. So the same output we are getting over here. So whatever query is written inside create procedure, okay, we'll get the similar output. It's a simple select query, but it is enclosed inside a function kind of thing. Okay. So as you see, I've not written the begin and end over here. So that's not always required, but we'll discuss further why begin and end is required. But without begin and end as well, you can create a store procedure. Okay. Now moving forward to the next step. So why is store procedure basically required? First of all, it is used for encapsulating complex logic. Okay, so if we are having, I would say 100 200 lines of SQL code. Okay, and we don't want to write it every time. Okay, so we enclose that inside a store procedure. Okay, and we simply use it for querying the data, same data every time. Okay, and how does it helps in improving the performance? So if you create a logic, okay, so inside a logic we are having, I would say, 10 lines of code. Okay, so what the SQL does is, if you execute this store procedure, okay, so SQL server is so intelligent, it will save the query map of this particular store procedure. Query, by query map I mean the most efficient way of querying that particular set of queries. Okay, so if the query map is already saved in our SQL server, the next time you run the same store procedure or same SQL queries, it will be executed in more faster. Okay, it will take less time. Okay, so that's how store procedure helps in improving performance. So whenever in an interview, if you ask what's the use of store procedure, okay, so that's what you need to answer. It is used for encapsulating the complex logic and also for improving the performance. Okay. Next is pivot and unpivot in SQL. Okay, so it's a very important topic. So pivot, by pivot, what do you mean basically? Okay, in if we go with the English terms, okay, so pivot means I would say turning the values. Okay, and unpivot means again reiterating the value to the same format. Okay, so in the same way, if we have some data in our table which are stored in columns and rows, okay, if I want the column values, okay, to become, sorry, if I want our row values to become our column values, okay, so for that I use the pivot. So for example, if we have these four values in our first four rows to go as the column. Okay, so for that, I will be using the pivot. Okay, let me show you an example of how that works. Create a table over here, table named air traffic. Okay, and inside this table, just give me a second. More clear. So inside this table, I will enter few of the values. Okay. Now the values look like is, we have the airline names, the month, and every month how many passengers travel with that particular airline. Okay. Now that's how the data looks as of now. The airline one, the month, okay, and the passengers. Okay. Now my requirement is, I want this month, okay, to be stored in the columns. Okay. So as of now, the columns are just airline, month, and passengers. Okay. But now I want this airline. The columns should be January, February, March. Okay. And inside January, February, March, I will have the total number of passengers. Okay. To visualize it, how it will look like now is, so I have this column as airline. Then I have Jan, Feb, and then March. Okay, so these are the different columns. And now, for example, this is airline one, airline two, and if you see the airline one in Jan is 1000, so the value should be 1000 over here. Okay, so airline one February is having 1200, so 1200 should be over here. Okay, so that's how I want our data. The data is now pivoted where the month goes as the columns. Okay. So how we can do that? So for that, there's pivot query. Okay. So I'll share the query with you. So in this query, how does it look like? So first of all, I will select the data that I want. Okay. So that is airline, month, and passengers. Okay. So over here, there's a subquery. So I'm doing it as select star from, and inside from, I'm again doing a select from air traffic table. Okay. So let's understand the first query over here. Inside this first query, we are having this subquery, okay, which is select airline, month, passengers from air traffic. Now this query is being used to create another table, which is a source table. Okay. Now this source table is, I would say, an inline table that is created during the query. So we are doing is select from this query, which is subquery, and refer it as a source table. Okay. This is our first part. And now I want to do it as a pivot. So I would say pivot that table, okay, where I want the values as passengers. Okay, so the values over here you see are going to be the our main values. So how we are going to sum it up? We are going to sum it up as uh, uh, so how we are going to group it up? We are going to group it up as sum. Okay. For example, over here you see only one value for airline January 1000. Okay. What happens if it is there one more value like airline January and 1200? Okay. So we need something to group these two values of airline 1 and January. Okay. So if there is January column of airline 1, okay, so January should have only one value. So in this case, it will become 2200 by doing this sum. Okay, so that's why we are doing this particular sum over here. Okay, so sum of passengers, and in the column I specify which all columns I want. It is January, February, and March. So it is for month in. So over here, month is January, February, and March. So I specify for month in January, February, and March. So when I run this particular query, you see, now my data looks like as I wanted. So airline 1, 2, 3, 4, 5, and January, February, March. Okay. So now what it did is it converted all the row values of January, February, March to column values. Okay. Now just to give you an example of how this sum works, for airline 1 January we had only one value. Okay, 1000. Now let's add one value as 1200. Okay. Now, when I again do this pivot, you will see the value of January is 2200 now. Okay. So what it did is it summed up the value of passengers for airline 1 in January and it showed to us. Okay. Now, if I don't want to sum it up, if I write max over here, okay. So what would happen is it will give the max if multiple values are present. Okay. Same if I do the average, okay, it will give me the average of all the values present for those two categories, which is airline and January. Okay. Now you see the average is 1100, 1000 and 1200. The average is 1100. Okay. That's how our data works in this particular manner. Okay. And same goes for unpivot. Unpivot is if we have data like this, okay, we want to unpivot it. Okay, there's similar query for unpivoting as well. Okay, I know the unpivot and unpivot is a bit complex as of now. Okay, but just for giving you a brief, if you come across any situation, you guys should know what kind of options you are having in SQL to perform to get these kind of data. Okay. Quickly moving to why pivot and unpivot is required. So it is used for financial reporting. It is used by HR services. Okay, because you just saw over here, our air traffic data had 16 columns, and it was a bit difficult for a person to understand the data of each airlines. Okay, because it is not very much clear. It is 16 rows as of now, but in production system it may be thousands of rows. Okay, but if we did a pivot, okay, then the data is more clear and crisp. Okay, if a person wants to see only for airline 1 of a particular month, okay, then he can easily use the pivot query to get the required data. Okay, moving to the next part, that is transaction and error handling. Okay, if you remember at the starting, we have talked about what a transaction looks like. Okay, so if a particular person is doing, I would say, a transaction in an ATM. Okay, So there are multiple steps performed. First step is it will check for the pin, if the pin is entered correct or not. Okay. Then it will check whether the balance is greater than or equal to the required amount. Okay. If this is true, then it will do the transaction and it will decrease the value of balance. So account balance minus required amount. Okay. And then it will commit the all transaction. Okay. Now, if anything fails in between this, if first step, second step, third step, if any of them fails, okay, then the whole transaction is rolled back. Okay. So that's what a transaction looks like. Okay. If a SQL statement within a transaction fails, okay, the entire transaction can be rolled back to its initial state. Okay. So that's what a transaction means in a SQL. Okay. And whenever you are working with some financial systems, so you will always come across transactions and error handling. Okay. Let me give you a quick example of how a transaction looks like and how it is created. Okay. You first of all the example, check the highlighted query as of now. Okay. The query that we see over here, there are two different insert statements. Okay. The first statement and second statement, and these are individual statement. This is not inside any transaction. These are simple SQL statements. Now what happens is, for example, I execute first statement, it ran fine. I execute second statement and it failed. Okay. So it will not roll back my first statement because these two are individual SQL statements. Okay. But if I do the same thing inside a transaction, okay, the query that you see over here, the highlighted query, if I enclose these two things inside this begin transaction and end transaction, okay, and now if any of the insert query fails, the whole transaction or whole SQL queries get rolled back. Okay. So that's the difference between standalone SQL queries and queries written inside a transaction. Okay. Just for confirmation, guys, I'm audible. My screen is visible fine, right? Just writing Q&A or give a thumbs up. Okay. Adivish, you cannot see the unmute. Say a Q&A. Okay, so that it is more easy for me to check. Okay. I will just reconnect in a minute. I think there's some internet issue. I will just reconnect in a minute. Hello guys, I'm again audible, right? And let me know once the screen is again visible. I think it is again visible now. So yeah, let's again start with transaction. So I was explaining how queries that are enclosed inside a particular transaction statement, okay, performs, it doesn't perform individually or standalone. If any of the queries fail, okay, it will simply roll back the complete transaction. So now let me show you a good example. I will create tables over here, accounts table, and it will store the account number and the PIN and their balance they are having. Okay, so let me create this account table. Seems like it is already present. So we'll drop it first, and again create it. So the accounts table is created. Now, what I want to demonstrate over here is how an ATM transaction looks like. Okay, so I will write the complete procedure for it as of now. Okay, so let me show you the first of all data. So data is over here like account ID, account number, and the PIN and the required balance. Okay, so I will write a transaction over here. Me show you how this complete transaction looks like. So first of all, I will begin a transaction. Okay. So inside a transaction, I will first of all check whether the account number and PIN matches or not. Okay. So if the combination of this account number and PIN exists, then I will go to the next step. Okay. The next step, I will check if the current balance is greater than the withdrawal amount or not. Okay, which was our second step. If that is present, okay, if that condition satisfies, then first of all, I will update the account. Okay, I will subtract the balance with the withdrawal amount. Okay, and if that particular transaction or that particular query succeeds, then I will give the amount which I will dispense the amount. Okay, so first of all, it should reduce the amount from the bank, and then only it should uh, dispense the amount. Okay, if all these steps are satisfied, then only our complete transaction will happen. Okay, now at every statement you will see there's a begin and end. Okay, so if any of the condition doesn't satisfy, we have the required amount of error handling over here. Okay, so I will share the complete query with you guys so that you can go and check each and every thing step by step. Now let me execute this particular transaction and show you with examples how this works. Okay, before that, I will declare some variables over here. So that's how you declare, already explained, that's how we declare variables in our SQL query. So declare variable name, data type, and the value. Okay, so I've declared the account number, PIN, and the withdrawal amount. Okay, so for the account number 12345, if we see we don't have any such account number in our database. Okay, so we don't have any account number 12345. So what will happen if I run this particular transaction? If I run this, it gives me invalid account number or PIN. Okay. Let's give you another example. So if I update my variables, now I'm using the account number which is present, okay, and the respective PIN and the respective withdrawal amount. Okay. So see, this ID is present and the balance is 1000. So what should happen? It should dispense the withdrawal amount of 100 and it should update the balance from 1000 to 900. Okay. Now if I run the transaction again, it gives me dispense amount is 100. Okay. And what should be the expected behavior? The balance should have been updated. Okay. The balance is updated over here. Now I will again show you the example where it should fail. Now the balance is 900. What if I say them I want 1000 rupees? Okay, so I've updated the withdrawal amount of 1000 2000. And now if I again run the particular transaction, it should fail with the error that the account doesn't have the required balance. Okay, insufficient fund in the account. So that's how the complete set of transaction looks like. Now, whenever you work in a transactional or OLAP or OLTP system, okay, you will come across the situation where you need to write each query step by step, and every query should roll back if any of them fails. Okay, so over there you will require, I would say, transactions will be helpful to you. Okay. Moving ahead, transactions and error handling. I just show you how we can do the error handling, like uh, in in the required query. Okay, we have this begin try block and begin catch block. So this try and catch block is present in every, I would say, programming language present over there. Okay, so we have that in Python, we have that in Java, we have that in R or even in SQL. Okay, so why error handling is required if any anomaly occurs. Okay, that is not programmed for the query. Okay, if a particular set of code is not programmed for the that anomaly, okay, then the error handling happens. Okay, so whatever properties are written or queries are written in the error handling part, that will be executed if everything fails. Okay, so that's why error handling is required whenever when we work with a good amount of big queries. Okay, now coming to, I would say, yeah, the last part of our SQL. Okay, so yeah, temporal tables. So what is temporal tables? There are scenarios where there are multiple updates happening in a particular table. Okay, so for example, if we have a particular table, okay, and it is having values like in 4 different columns. Okay, so in this, if any of the rows are updated, okay, and we want to see the history of how that particular data or when that data was updated. Okay, in some of the scenarios, these are very helpful. If we want to keep a track of record of when it was updated, what was the previous record, at that point of time, the temporal tables come in help. Okay, so the main use is to basically, I would say, to track the history change of the data present in the original table. Okay, so how a temporal table is created? It is created just like a similar table. Okay, just we need to add a query at the last with system versioning on and the history table name where we want to store the history. Okay, so let me show you an example of how a temporal table is created. So just like we create a simple table, the create table employee query, okay, and at the last we need to add this with system versioning on and the table, the history table that we want over here. Okay, so that's how we create a temporal table or a table which will store the updated records of the parent table. Okay, so I will run this query and create the employee table. Now I will insert few values over here. I've inserted values over here. Now I will get the query these two. I will query these two tables. So the first table over here, if you see, this is our main table. So employee table 1 and 2, name, title, salary. And now you see there are 2 columns, valid from and valid to. Okay. So I will not enter any values in valid from and valid to because these are a part of our temporal table structure. Okay, and it will be automatically generated whenever a row is entered or updated. Okay, so you see valid from generated always as row start and valid to generated always as row end. So these are the predefined, I would say, the predefined queries in SQL. Okay, So as the name suggests, valid from will contain the values when the data was created or entered, and valid to will contain the value when the last, or I would say, when was the last data entered or updated. Okay. So if I've inserted a value over here, now let's update and see what happens. Update this query, update employee. Title, I will update to senior engineer, where ID is 2. So where ID is 2 for Jane Doe, when the title is engineer, okay, I need to update it to senior engineer. Okay, so I updated this complete record. And now when I again do a select over employee and employee history, you will see what happens over here. The data was converted to Jane Doe, title as senior engineer. Okay, and the valid from and valid to is also updated. Okay, so if you compare the valid from and valid to of the first two rows, okay, you will see the first row was inserted at 519 and second row is being inserted at 520. Okay, so this is our new row. Okay, and in our history table, the employee history table, which basically stores the history. Okay, over here it stores the historical change, what kind of data was updated. So ID2, Jane Doe, and title was engineer, and this was his salary, and it was valid from 5/19/14 and the time when it was changed. Okay, so you will see valid from a first row. Sorry, that's too big. I will, yeah. So valid from a first row matches with the valid from of second row, which means these two data were updated, inserted at same time. Okay, and valid from of new data matches with the valid to of the previous data, which means a data which was earlier valid till 520, okay, it was updated at 520, okay, and new data was inserted at 520, which denotes a senior engineer. Okay, so by this way, we store the historical data of in a particular table. Okay, so this comes very handy when we are basically dealing with this kind of HR data or sales data where a person wants to see what was the history of a particular person. Okay, so it's a very good interview question which comes in our interview. Okay, how we manage our historical data. So that's when temporal table comes. Okay. Okay, so yeah, this was a complete end to our SQL, and we will next